So in this example, we're going to do what is known as an invert. And another word for invert is to do the inverse of something. And inverse basically means to do the opposite. So the inverse of addition, of plussing something, is subtraction. They're opposites to each other. And that's basically what we're doing. So we're not going to do slides, we're not going to do switches, we're going to do an invert, or also known as doing the inverse of something. Alright, so we'll start with question A, which is calculate the value of theta correct to 1 decimal place. Whenever we see this symbol, it's a Greek letter, and we pronounce it theta. You'll notice that in these examples, we're trying to find the angle this time. And whenever you try to find the angle, that's when you do the inverse. Alright, so the same steps as before. We start by labeling sides. Opposite the right angle is the hypotenuse. Opposite the marked angle is opposite. And finally the adjacent last. Okay. Now you'll notice that our adjacent has a number of 6.7, our opposite has a number of 2.4, and our hypotenuse has nothing. So we just cross it off. We're not going to use the hypotenuse. So opposite and adjacent, where do we see that? Well, we see it at the end of the acronym. Here is our opposite and adjacent here. So we're going to use tan. So we'll write it down, tan, and next to tan we write our angle, which in this scenario is theta. We don't actually know what it is yet. Equals, and put our vinculum bar. Now we need to figure out what goes at the top of the vinculum bar and what goes at the bottom. You'll notice that after tan comes opposite, or O, and O is 2.4. So that needs to go at the top. And adjacent comes last. So adjacent 6.7 goes at the bottom of the fraction. So we followed all the same steps as we did before, and we come to the last step, the step that we call invert. Alright, so what we're going to do is we're going to leave theta on the left, and we're going to bring tan to the other side, but we're going to write it a little differently. We're going to write it with this little -1. And this basically means inverse tan, or the inverse of tan. And in brackets we'll write 2.4 over 6.7, like so. So we need to bring up our calculator, and you need to look for what is known as an inverse tan function. And you'll see here, you'll find tan, and above it you'll see tan with a -1 in red. So we're going to go second function tan, and we get our inverse of tan, tan to the -1. Really important that you use brackets here and go 2.4 divide 6.7, close the brackets, equals, and here's our angle here. It wanted it correct to 1 decimal place, so we'll write it as 19.7 degrees. That's what our angle equals. Alright, let's move on to example B this time. Opposite our right angle is hypotenuse, opposite our marked angle is opposite, and adjacent's last. So we notice that we have a value for A, for adjacent, and we have a value for H, hypotenuse. So this one has to be the middle part of our acronym because we have adjacent and hypotenuse here. So we're using cos. Cos, and next our angle, which in this case is theta. We're trying to figure out what theta is, equals, and then the vinculum bar, following all the same steps as before. You'll notice that adjacent comes after cos. Adjacent is 2.2, that goes at the top, and hypotenuse comes last. Hypotenuse is 3, that goes at the bottom of the fraction. Now, if we want to find theta, or the angle, we need to bring cos to the other side. But in order to do that, you need to use what is known as inverse cos, cos to the -1, and making sure that your fraction goes in brackets. Like I said before, this is really important. If you don't do it, it can really throw off your solution. So, cos inverse, second function cos, and we get cos with a -1, making sure we put our brackets in, 2.2 divide 3, you can use the fraction button as well if you want, equals, and we get 42.83342, so on. Now you'll notice the question, it wants you to give it correct to the nearest minute. That means you need to convert your solution into degrees, minutes, and seconds. We're going to do that. Second function DMS, and we've got 42 degrees and 50 minutes. Now, I'm going to write that down, but I want to talk a little bit about that as well. 42 degrees, and I think it was 50 minutes. All right, really important that you double check what you're doing, because sometimes it can round up. Sometimes it can round up to 51 minutes. And what you need to do is you need to look at the calculator and go, all right, how many seconds do I have? It's a really small amount. It's less than 1 second. It's 0.3 seconds. So we're definitely not going to round this up. At what point would you round it up? Well, talking about seconds, I'll just write it up here. If it's 30 seconds or above, then you've got to round your minutes up. Remembering that 30 seconds is the halfway mark. So anything above 30 seconds, or even if it equals 30 seconds, you would round it up. So you might, in this scenario, if it was, let's say, 30 seconds, you would say 42 degrees, 51 minutes when you write down your solution. Anyway, that concludes our video, just finding the angles on right-angled triangles. Remember to read the description below for links to workbooklets that relate to this video.